Hey everyone, welcome back. So, if you are a DevOps engineer or just thinking about beginning your career as a DevOps engineer and thinking what you need to learn, you probably heard the term Terraform mentioned about 1,000 times, right? So, what I'm going to do today is that instead of going back and forward and stuff like that, we are going to cut right through the noise. And in this video, I'll show you what Terraform really is, why it is crucial for modern infrastructure management, and just how you can start using it like a pro, or at least start to learn it. That's very good thing to do. So, first of all, what Terraform is and why you should care. Well, Terraform it's a infrastructure as code tool developed by the HashiCorp, and it was like one of the first ones, I believe, but it is very popular and one of the biggest one for sure. And basically, it lets you define, deploy, and manage the infrastructure using the human-readable configuration file. So if you use something like IRM templates for Azure and compare that to Terraform, it would be like an eye-opener for you. I can promise you that. And in DevOps, where speed, consistency, and automation, it's everything. Because of that, Terraform is pretty much the powerhouse. So what's the deal with the Terraform just in general, why it really matters? So, first of all, if you want immutable infrastructure, you get it. If you want repeatable environments and if you want to deploy to dev and then have some sort of a certainty that your production environment will look similar, then you have it. And finally, if you want to run them in a CI/CD pipelines in a very easy way, once again you have it. On top of that, Terraform have a very big ecosystem around it, and you can test your code, you can optimize it, and there are a lot of tools to help you write better Terraform code. So once again, you have it. So with that, let's quickly jump to just to realize how it actually works and what is under the hood of the Terraform. So at its core, Terraform actually uses three things. First of all, you have providers, and that's the way to interact with APIs of different services. So, for example, if you want to use Azure, then the API to interact with Azure would be the Azure provider, and it is actually developed and maintained by Microsoft themselves. Same thing goes for the Kubernetes or GitHub or AWS. You can just name anything, and there would be a provider for Terraform. I once, during the uh, code challenge for Christmas event, if I'm not mistaken, or something like that, there was a provider for Terraform to build your own Christmas tree. So amazing. It was virtual, obviously. But anyway, the next step that you need to have is resources. And resources, it's the way how you define different components in your code to be able to be deployed to the real world or to your cloud provider. So if you want to create a database, a virtual machine, a web app, all of those things, those would be resources that you would need to define in your code. And finally, the biggest probably advantage of the Terraform is a state file. The state file, it is used to track how your real world infrastructure compared to what you have in your code. And basically it's like a snapshot of what was last deployed. So how Terraform will work is that it will check when you will try to deploy your changes, for example. It is going to check the state file. It is going to check the actual state of the infrastructure, and it's going to check the resources that are defined in your Terraform files, and then it will compare all of that and we try to understand and plan what it needs to do so the real infrastructure matches what you want to have, and then it will update the state file to just have an updated version of it. So With that, basically Terraform uses the declarative approach, and you describe what you want to have. It's because of that it is really easy to read and maintain in a long term. And yeah, I've said a lot of words, so probably let's jump to a little bit of an example, and I will open my screen. And today, just for the fun of it, let's use AWS instead of Azure as I do it usually. So over here right now, you can see on my screen probably that I'm in a US East region of states, and I want to create the EC2 instance, for example. Over here right now I have nothing at all. And how to do that, let's quickly Google. So let me close this so it is easier to understand how you can easily Google, because other advantage of Terraform is amazing documentation. The way to work with it, it is very easy. So you can just Google for Terraform EC2 AWS, and the very first item that you will have, it would be a link to the documentation from Terraform, and yeah, you can just open it and see what you can do. And here there would be an example usage of this resource that should provide the EC2 instance resource. But a little bit down, you can just say that there is a new way of doing it using the SSM. Resources, and you can say that you want to copy all of that stuff, and let's open Visual Studio Code. I don't have anything over here, as you can see. So let's create a new file, call it my AWS TF, and TF it's an extension for the Terraform files, and let's paste it. So far it looks good, very small, but it will not work, unfortunately. What you need to do is to define a provider, and that's how you do it. Once again, copy pasting all the way, and here you have first you say that that is a required provider for the AWS that you want to use, what version of the API you want to use. Then you need to configure it just a tiny bit, and here you just say that I want to use the region US East 1. So the one that I was showing you over here from the North Virginia, those are the codes for the regions. And finally, actually, according to the docs, once again, if you scroll down a little bit, you need to authenticate, obviously. I've already done it locally, and my console, it has correct environment variables set up. With it, you just now need to follow the usual procedure of Terraform. So first you do Terraform init, and that will download the required providers locally so we can run them and use them. It is usually quite fast. Yep, you can see it's already done, all green. After that, with that code, you can run Terraform plan, and what it will do, because I'm running it locally, it will load all of the Terraform files into the same blob in memory, and will try to understand what to do with them. With that, when I run that plan command, you can see that it actually generated the state file for a short period of time, because I'm using the local backend at the moment, and it is saying that it actually wants to create a single resource that would be the AWS instance and with the name of web, and with a tag of hello world, which is the name of it. Yeah, I don't really care right now, to be honest, with that, what is inside of this, and we can just run Terraform apply, and it will say that, it will run the same plan again, and will say, do you really want to run it? And I can definitely say yes, please. And in about 10 seconds maybe, or maybe a little bit more, it will create the AWS instance for us, and that would be our EC2 instance. Yeah, sorry, it was 14 seconds. And now if we will go back to Firefox and refresh this thingy, we will see that there is a new Hello World EC2 instance that is running as a v3 micro, and at the moment it is still initializing, so it was just a resource that was created and nothing on top of it. But still, it is amazing and very easy way to manage your infrastructure. And just imagine that you need to manage multiples of those. You want to deploy your EC2 instances to dev environment and test how it will work over there, and then redeploy them to prod instead of clicking in the console and praying pretty much that you wouldn't make a typo or mistake. You can run all of that from your code. You can commit that to your Git repository, and even better, you can define CI/CD pipeline that would trigger this on every commit and deploy it automatically into all of the environments. So it's just great to have the tool like that. That's what I wanted to say. Uh, so what you should do on top of that, you can see that right now I have the Terraform state, and it's just a plain text pretty much of what was really created and saved. And actually, if there would be a passwords or keys or anything like that, that will be saved in the Terraform state file as well. Because of that, you need to care about this as much as you can. And the best practice is to use a remote state actually instead of the local one. So if you work on a team, then you want to share the knowledge what is inside of your real infrastructure. Because of that, you want to use a remote state, but it's probably a topic for another video. Then you can also write the code in a much more convenient way or more maintainable way with modules, and that one is definitely, once again, we will come back to that later. And finally, you can actually use Terraform Cloud or Terraform Enterprise that will help you to manage the state, teams, and runs all the deployments at scale, but that's not really needed. And I usually use just Azure DevOps or GitHub Actions, GitLab, Jenkins, you name them, to actually do the deployments. One last thing that I wanted to just quickly give as a tip, because I see that quite often and I want you to avoid this, is first of all, you need to version control your Terraform files, and the infrastructure code should be treated as a regular code, and it needs to be committed to your repository, it needs to be maintained, and it's just a code. Then when you run your apply, it's always better to run Terraform plan, and even better, just a hint, if you use GitHub, for example, or Azure DevOps, then you should have policies to not deploy, to not commit to your default branch by default, and instead you need to create a pull request to merge into your default branch. And even better, if during this pull request process, you would run Terraform plan in an automatic way, so someone who will be reviewing this pull request, they will be able to see what is the end result if they accept the change as a plan, and then the apply would be much easier. The next thing that I would really recommend, but it is over here pretty much, that you log your versions of the providers and you upgrade them as your usual dependencies. That will help you to just keep it up to date, but not too fast. So providers can change, and there might be some deprecation of resources and so on. And if you stick to a specific version of the provider for a time being, it's actually easier for you, but you would need to maintain it in the long term. But I would still recommend to lock the provided version to a specific one. And the last, but definitely the biggest one, to please never, ever hardcode your secrets. use something like Azure Vault or HashiCorp Vault, or at the very least the environment variables from your CI/CD tool, but do not hardcode them into the code. Alright, with that being said, I would repeat that Terraform is an absolute must-have skill for DevOps engineer today. It brings order, it brings automation and scalability to the wild world of cloud infrastructure, but you can use Terraform for pretty much anything, and it's a great tool to have. So yeah, just start using it, and on top of that, please drop a comment below, or maybe like this video, and definitely please subscribe. It will really help me to realize how it's going. Good luck!